So what I wanted to talk today a little bit about was the digital practice in digital design and delivery, and how it kind of is related to steel. Just before we do that, a quick introduction. Walter P. Moore, we are a US-based firm, about 80 plus years in business, with 20 offices worldwide, and an office in Pune with 75% team. All right, with that I'll move on. So digital transformation, I mean, we are living in the age of digital transformation today, right? I mean, there's digital disruption in everything that we see. And even the government of India with Digital India, they're kind of promoting digital in all sorts of industry sectors, all sorts of governance. And so construction, AEC industry, they're not immune to that. Digitization and the disruption is taking in all sorts, all forms. Just to kind of look at what digitization has done, I mean, the slide is pretty self-explanatory with what it has, Uber and Ola have done to taxis, what retailers have gone through with Alibaba and Amazon, with hotel chains, with Airbnb and Facebook. So that's where it's headed. But what we're going to look at is that the AEC industry, the architectural engineering and construction industry, this was a nice infographic prepared by Boston Consulting. And as you can see, I mean, it has everything from prefabrication, modular construction, advanced building materials, 3D printing. These things are happening today. Autonomous construction with the help of drones. We talked about that earlier in the Trimble's presentation. Big data, predictive analysis, parametric modeling kind of things, augmented and virtual reality. So these kind of things are helping the design industry kind of do a lot of things, and steel is an important part of that. Wireless monitoring and connected equipment, cloud and real-time collaboration, and the building information modeling. So those last 2-3 things is what I'm going to focus on, not on the entire thing here. So what today we're going to look at is that the top left-hand corner, the old way of doing things, a set of drawings, designs, and we'll kind of look at what is the digital, what is it that it's kind of the digital transformation is taking place in this space. So kind of looking back at it, why do we need it? So this is a survey that was done and asked to engineers and architects is, in which areas do you most frequently spend more time than expected? And you can see the responses are pretty, the communication, project execution and coordination. A lot of time is spent in conflict resolution, dealing with mistakes and rework. So if these are the 3 things, if we just look at this itself shows us that there has to be a better way of doing things. And obviously there is. And this is where the digital practices come into play. So what is the need for digitization, right? So to address the complexity, we know the projects are getting more and more complicated. We just looked at the architectural presentation where Skywalk. So then projects are getting complicated. Owners want to look at many more options. So it's optioneering. We just can't show options. You have to engineer the options. We have to reduce waste, taking care of sustainability, unleash the creativity, allow ourselves more control, provide higher levels of quality and fidelity, and deliver consistently. So for all these reasons, I mean, digitization is the need. But to do that, I mean, we definitely have to change our mindset. I mean, we can't think that we create drawings. No, we create data. That's what we are creating. Our drawings are accurate enough. No, our models need to be machine readable and fabrication ready. So that's what we need to do. We don't work with just our software. We work with where the client likes to work. And the client is any client. I mean, it could be the architectural, the fabricator, the final owner. And there's always a thought process in engineers and architects that sharing too much information is risky. Well, not sharing too much information is going to be risky, so on these challenging projects. So we need to change our mindset on how we think. Okay, so what is digital practice? So let's kind of look at that. So we try to answer that question from our firm's standpoint. And so our digital practice is a firm-wide approach to leveraging information using technology, helping our creative personalities turn knowledge, experience, and innovation into value. At the end of the day, we have to create value. We can't do it just for the sake of doing it, right? But if we kind of start looking at it, our firm is not important. I mean, these things just vanish away. And at the end of the day, digital practice is how we leverage information using technology. That's all that there is to it, right? So before we move on to it, what is it not? I mean, let's not not kid ourselves. So it's not just blind application of tools. It's not doing just cool stuff with no value, just for the heck of it. It's not about delivering faster with a button. It's not about just using tools and solutions and software with a push of a button. So it's garbage in, garbage out. So you have to produce value. Not producing deliverables without review. So digital tools actually help us, on contrary, to kind of check what we are doing. There are tools which when you can run through your designs and make sure that you are doing the right things, make sure that they fit within the rule of thumbs. So basically, it's a full data-rich delivery where design information effectively flows and accurately builds through the entire project lifecycle, and geometry, analysis, and document models stay in sync at all times. Well, that's a mouthful. Something's not right here, but the models is the important part here. So it's the models that are important. So what are the models that we are talking about here, right? So the different models is there could be a client model, a delivery model, an engineering model, analysis model, and a documentation model, fabrication and construction model. So all these different models have to work together, but the common theme in there is they rely on data. And this data is how it can be viewed, manipulated, exploited, augmented, tabulated, and throughout the project cycle. So that's what is important. So for this data-centric focus is critical to a successful digital practice. And so if we think about it, all these different models, the data is the model itself. So that's the data that we're talking about. So it's about how is it that we can more effectively use the data, right? So we need to develop a common data platform. So all these different tools that we use for the different models that we look at, they have their own systems and their own data that they're using. But how can we all bring it together? So let's look at a few examples, right? A common platform for data signifies interportability. So the data should be able to flow. So a lot of people we know about Revit and Tekla. So the data should be able to flow between the two, all right? So now it's a little bit more complicated project. Now you have Revit and Tekla, also engineering tools like SAP and ETABS. Okay, so the data now has to flow between all of these 4 different things, okay? Now if we add to that, let's say there's a tensile fabric, there's a software like GSA, there's Strand, there's Navisworks, which is used for coordination. There could be Rhino, like parametric modeling software that is used. So now the data has to go between all of these different things and connect it. So if you make a change in one of these, it has to effectively connect and change the different things as well. So how do we do this? A lot of companies like Trimble, they have solutions where their softwares talk to each other. But if we are talking about different software, different kinds of things, so what we kind of ended up doing is we had something called the CID. I know in CID, I'm not talking about this CID. So not this CID, but the Central Information Database. So that's the CID or SID that I'm talking about. So what this is, it's basically a database where every single thing in each different model is tagged and it has all its properties. So you can see, it could be the location property, the property, beams, columns, braces, what is that member, what is the angle of the member, what are the dimensions of the member, is it a steel member or concrete member, does it have studs, the camber. So all the detailed information is stored in the SID. And once we use the SID or the CID database and kind of connect it with Power BI, the business intelligence software from Microsoft, the data becomes really useful. So now what the data is doing is you can look at different things. What is the tonnage? What is the steel tonnage? What are the column tonnage, beam tonnage? So you can classify all this information. You can slice and dice the data for your advantage the way you want it. So now if you look at it, on the top right of corner there's can't read it very well, but the different profiles. So what are the different shapes and sizes of beams that are used? Okay, so the different sizes of beams that are used. What are the shear reaction for those sizes? How did it change? So there's data that can kind of connect to all these different things. And not only that, if you look at this, so if you take any particular model, there's different dates here on the top and the different members. So the life cycle of that project, of that model or the structure, so how did it change? It used to be this size, and as the design developed, it kind of changed, and so these are the different changes that took place. So you can go back and look into history and why the tonnage changed, what happened, what was the life cycle of that project. So that's something that can be looked at. You can look at a single snapshot of a single member, that how it changed, or you can look at a particular time, what was the different member sizes. Same thing, you can do it, change it just to look at one member and why it changed. So if you want to go back and owner asks you, okay, why is it that this member changed from this size to this size on this particular date? You can go back and, oh, okay, so the reaction changed over here, and that's why the member had to change. So this kind of information is what kind of drives the digital practice. So we've always used different models, right? Like we talked about, there's a documentation model, engineering model, Tekla model that used for fabrication. But till we kind of bring all this together with this central information database, they're not all connected. If you want to make one change in, let's say, your design model, then it has to change everywhere. You don't have to manually go and change all these different models. There's different trades that are involved. I mean, there's the facade consultant, the structural, the architect. So all this, if all these models are connected, then that one single change in one location can affect everybody, and you can see what happens there. All right, so what are some of the tools that are used? This may be redundant to a lot of you. For the geometry, we know Excel, but there's a lot of parametric modeling tools like Grasshopper and Rhinoceros, obviously Dynamo, SketchUp. So these kind of tools are used to kind of create geometry. Analysis, we know all the different analysis softwares that are used, but now these need to be connected as well. There's membrane and other software that are used to design tensile fabric structures that need to be connected. There's visualization software that need to be connected to make things simpler for our owners. How do we present the data to architects and clients? So those need to be connected. Documentation things like we talked about, Revit and Dynamo and a bunch of other ones. So these all need to be connected, right? And obviously there's parametric modeling. So what parametric modeling is, and I know the architects are ahead of us in this, the structural engineers and other engineering disciplines haven't been using it as much as we should. But what parametric modeling is kind of where engineering is kind of going towards a little bit, I would say, dipping its toes in artificial intelligence, right? So if you change different parameters of a particular structure or a particular problem, how does that affect the entire structure? So there's different ways. So when we are doing things manually, or even if we are using engineering software, we can run maybe 10 different options. But to run thousands and millions of options, this is what is used. So this is a simple case of a stadium where the owner wanted at least 60% of the seats to be covered in shade. But now, depending on the time of the day of the year, the sun is going to be at different angles, so solar path study has to be done. And then from that, you can come up with different solutions. So what we did here is, this is a Grasshopper and Rhinoceros model. You can see the data over here is changing. And these are the things. And you can see the percentage shading is 59, 60%, and so on. And this is how the canopy changes. So it's not only changing that, but it's going to the engineering models, calculating that, and coming up with the economical model, and then trying to come up with what is the most economical kind of curvature here, or the shape of the roof that will come up with the most economical steel structure. So that's kind of the power of doing parametric modeling. But that's enough theory, right? So let's look at a sample case. So I know most of you must have seen the movie Avatar, right? So they've created the islands of Pandora, so the floating islands, right? So we worked with Disney, and so this is an actual project in Orlando where they wanted to actually make these floating islands. So you can see the progression of the thought process here. So we are working with Disney's Imagineering team, and these guys are kind of at the highest level of digitization and whatnot, because they've already created these things in the movie, and we know that they use a lot of digital tools to create these kind of structures. So those were the starting point. Those were the artistic impressions of what they wanted to do. They actually built some models, if you can see. They actually built, okay, this is what we want it to look like. This is what it looks like in the movies. So this is what we can do. And then it kind of, okay, this is how we can support it. So that's how it works. And then you kind of scan the models. They use tools like the ZBrush. Again, Rhino and Grasshopper are the parametric modeling tools which are used to do this. And then it goes into the analysis software, and finally into something like a Tekla, where you can come up with a documentation and a fabrication model which can be directly fed in to the fabricator. All right, so our wireframe was first prepared in Rhino, and you can see, I mean, the different routes and things like that. So this is where the supports come from. So these are the manual routes which will support the entire structure. So from that, you start building, okay, this is how your rock work is going to look like. And then you kind of start looking at these constructability of the connections. How are these things going to actually come together? So you start looking at the little bit of zoomed in sections of Tekla and how are these things. So the fabrication for something like this is very critical. And we also did a 3D printing of this. And so when the artists, they kind of look at it, they can say, okay, this is what it's going to look like. And they kind of get a better idea of what it is that they're getting into. So one of the tools that the Trimble guys talked about was VR. I mean, so you can actually look at virtual reality and look at how it's going to look like. How is this going to look like? So this is how the model finally looks like. And this is during construction. So the actual floating mountains of Pandora, they are now built. So this is how it's the world of Avatar. If you look at just this one piece, so that kind of gives you the size and scale of it. This one piece is kind of this piece over here. And this is what it looks like today. So all this, I mean, this floating mountains of Pandora, it's a steel structure. We talked about steel as a structural element, as an ornament. So there's various different kinds of things that steel is used for. So something different that can be done. So digital workflow, so this cool structure, you say, okay, yeah, that's great for you, but what about me? For simple structures, I mean, is there a need for digitization for simple structures like this? And so the answer is yes. I mean, so for everything, I mean, we don't use our smartphone only to do complicated things. We use them to do simple things as well, right? I mean, it tells, if I look at it, it can tell me where my son is right now. I can track that. So it's making life simpler for us. So for all the same reasons, I think there's many small tools that we can develop in the digital where you can take just an architectural to structural model maker. So if you get an architectural model, let's say in Revit, you can easily kind of convert that into a structural model. This is a small video that shows how it does it, but I don't think you'll need to sit through it. Again, so for big structures like this Minnesota United FC Stadium, some of these things cannot be done without some sort of digital practice and digital tools. This is another project that we are currently working on in Ahmedabad. This is the Motera Stadium project. This will be the biggest cricket stadium in the world once it's built. It has a seating capacity of 110,000 seats, which will be bigger than the MCG, which is currently the biggest cricket stadium in the world. So we are doing the tensile fabric roof design for this for L&T. And this is kind of maybe a couple of months old shot, so it's under construction right now. But maybe in our next conference like this, we'll be able to present on that. So what is digital practice or digital versus manual? How does it work? So it's like you can see that it's more empowering, it's not frustrating. When you're redoing the work, it can be a creative process. It's more learning, not thinking. It's kind of interesting, not boring. It looks like my timer is on. Okay, so let's look at a time spent versus task size, right? I mean, if there's a task that somebody needs to do, two people start doing it. One does it manually. The other one says, okay, he does it manually. Gets annoyed, too much work. So writes a script to automate that. Okay, I'm going to write a script, and okay, so this manual, boring task, I can over and over again, I'm going to do a small program to do that. So this manual guy makes fun of it, complicated digital methods, I'm making progress, he's not. But once the script is run, I mean, look who the winner and the loser are. So that's where it's about saving time, about accuracy, and that's what digital tools can do for us. This is another infographic that's very interesting. Kind of if you see in 2016, 2017, BIM implementation, those are the early adopters. So we need to make sure that we kind of come and start climbing this mountain, right? I mean, you don't want to be this guy here who still wants to use his pencil and paper. So you want to be kind of catching up with the times. And that's where with the smart cities, smart buildings that we talked about, so these kind of things which are required to do that. So don't be this guy who's not adopting technology, scared of virtual reality, because believe it or not, these are things that are happening today right now. I mean, we use, in meeting rooms, there's a small lens that can be applied on top of our phone. I should have brought it today. and everybody sitting in the meeting room looks at it and solves a problem, virtual reality. You no longer even need those big glasses. So that's where we are headed, and so we need to keep up with the times. So that's my presentation. I think the future is now. And